And now a brief description of tension, characteristics of which we can easily demonstrate. So first of all, we have a character pulling on a scale with a rope attached to the scale, and it's just tied off at some place. All right, so it's just tied off and he's pulling on it. Well, the scale has a reading, and the reading of the scale is equal to the tension in the string. It's how much force is pulling on the string, so it's also the force acting on this point that's tied off. So, what is the force at B? It's equal to the tension in the rope. Now, we're going to add another person, and that person we'll call B for scale B. And they're just going to hold on to the scale. They're just going to hold it, not pull, while A pulls. Can you do that? So B just going to hold, A is going to pull. So what do the scale readings indicate at that point? Well, if we again demonstrated this, which we can do, you will see that the reading on scale B is the same as it is on A. There is no difference. So really, how is this different than just having it tied off? And really, there is no difference. There's tension in that rope, just like before. Now we're going to reverse roles, and person A, you're just going to hold on to the scale. You're not going to pull, while B pulls. So we're reversing the roles. And now how do the scale readings compare? And again, they are the same. So if we demonstrate that, we can conclude, or if you believe this description, that no matter which end is doing the pulling, the tension is the same at both ends. In other words, neither B nor A can just sit there drawing this scale close to their bodies and focus in their mind on just holding it and not pulling. Because in holding it, you really are pulling. There's really no difference between holding and pulling. All right. Now, I suppose that was unnecessary as I stereotype the hippie generation. Anyway, what about what's going on in the center? So far nothing seemed that strange. But what's really interesting is in the center of the rope. So we have the scenario that we had before. So we have it end to end, but now we're going to stick a scale in the center. And my question is, what's the scale going to read now? Keeping in mind that this scale has mass and it's not accelerating. Okay, it is not accelerating. So this side is pulling to the right, pulling to the left with forces equal to the scale readings. So your job is to figure out what the tension is there. Is it zero? Is it half? Is it double? Or is it the same? Or is it maybe something else? So you got to vote. You're voting in your mind right now. You're deciding what's the scale reading going to be. Again, no net force. Zero net force. So you have your answer, right? Of course you do. It's zero. No, it's the same. And if you think through it, it doesn't surprise you too much, because if you just focus, for instance, on this part, this point here is being held by this whole half on this side. So you could erase all this and just think of holding this on a nail or something. And how's that then different than the scenario here? Well, it's not. The tension is the same everywhere in the entire system between the two regions where it's being pulled. Does that make sense? Everywhere along here, the tension is the same, basically at every single point. And even though there's no net force here, and I talked about mass of the scale, it doesn't really come into play. There's no acceleration, there's no net force, but there's still tension. And at any point you look, there's a force to the right and a force to the left, held by the cohesive forces in the material of the rope itself, or the chain or wire or whatever it is. And they cancel at every point. There's no net force, but the tension is there. So from the point of view of the left-hand side holding it from here, there's a tension on this, a force that causes the spring to stretch and the reading to occur, and we could reverse the roles just as well. So keep that in mind, because I will certainly try and trick you with this on either a test or a quiz.